So let's go back to considering hot air balloons. Hot air balloons have a buoyancy force because they displace some of the air. As we'll see with the ideal gas law, there is air inside a hot air balloon, but the air inside the hot air balloon is less dense than the surrounding air. So another example of this is actually with helium balloons. So let's look at a helium balloon now. Here's a helium balloon. This is filled with helium gas, which is much less dense than the surrounding air, which is mainly nitrogen molecules with a few oxygen molecules. So this helium balloon will float if I let go of it. And when I let go, it accelerates up towards the ceiling because the buoyancy force is much greater than the weight force. So there's two forces acting on this helium balloon. It's got the buoyancy force pushing it up, and it's got the weight force which is pulling it down. Now one very important rule in physics is that for a body to be stationary, all the forces acting on it have to be in equilibrium, which means that all these forces need to cancel each other out. So if we add mass to this helium balloon so that we're increasing its weight, we can make that weight force, the downwards force, equal to the buoyancy force, which is the upwards force. So to add weight to it, let's tie this piece of cardboard to the helium balloon's string. There we go. So now when I let go of the helium balloon, it's slowly accelerating downwards as the weight force, the downwards force, is now larger than the upwards buoyancy force. So what we can do now is we can snip off little bits of the cardboard to decrease the weight force until these two forces are equal. Okay, still going downwards, so we need to snip off a little bit more. Going downwards, but accelerating more slowly. Going downwards very, very slowly, so just a little bit more. Very, very, very slow downwards. And now the helium balloon is in perfect equilibrium. It's staying exactly where I put it. So now let's do a calculation involving this helium balloon.
So the question is, a balloon has a volume of 3.50 litres. The mass of the balloon and string is 2.0 grams. It is filled with helium with a density of 0.1786 grams per litre. If air has a density of 1.22 grams per litre, what minimum mass must be tied to the balloon to stop it from floating away? Okay, so let's consider what's going on. Here we've got our balloon. Now the balloon's got a buoyancy force upwards. And this buoyancy force is equal to the weight of air displaced. That's Archimedes' principle. And downwards, we tie on a mass, and it's got a weight force. Now, to stop the balloon flying away, this buoyancy force and this weight force need to be equal to each other. If the weight force is larger than the buoyancy force, then the balloon will not fly away, but the limiting case with the minimum mass is when the weight force is equal to the buoyancy force. So let's start by working out the weight force. So there's three things contributing to the weight force, three masses. We've got the mass of the balloon plus the string, which we're told is 2.0 grams. We've then got the mass which we tie onto it, which we need to find. So let's call that M. And then finally we've got helium inside the balloon, and so we've got the mass of that helium as well. So that's the density of helium times the volume of the balloon. And then to make it into a weight force, instead of just a mass, we need to multiply that by G. So the density of helium is 0.1786. The volume of the balloon is 3.50 litres, and so we have the mass of the helium inside the balloon is equal to 0.625 grams. And so we've got 2.625 grams plus the mass in grams times G will be our force in millinewtons. Okay, so now what we need to do is work out this buoyancy force. So the buoyancy force is just equal to the weight of the air displaced. So that is equal to the mass of the air times G, and the mass of air is the density of air times the volume of the air, which is displaced, times G. And so this is equal to 1.22 times 3.5 times G. And so this is equal to 4.27 G. Now what we've said is that our buoyancy force must be equal to our weight force. So we can set this one here equal to this one here. So we have 2.625 plus M times G is equal to 4.27 G. These G's cancel out. Now all these masses are in grams, and so our final mass is 4.27 minus 2.625. So this gives us 1.65 grams is the mass that must be tied to the end of the balloon there.